So now there we were talking with respect to the transfer of the energy from one level to another level. And in a food chain, there is a specific sequence on which an organism feeds on another organism. So based upon this, so there are some other terms called bioaccumulation and biomagnification. Okay, so
Sir,
yes,
sir,
yes.
in case of pyramid of numbers, we can say that there is always a upright or the inverted we can find in the marine or the terrestrial ecosystem.
So can you come with your question again? In aquatic ecosystem?
Sir, I'm asking that the inverted, when it comes to the inverted pyramid, so where do we find in the number of pyramid of numbers? In the aquatic or in the terrestrial?
Inverted can be seen in terrestrial. And if tree is an ecosystem, so then we can have it as an inverted. We have saw an example of inverted ecosystem, pyramid of numbers. So you see here, we have taken tree also can be an ecosystem where several organisms can live on a tree, like you see here. So on a tree, some herbivores are living, and in herbivores, several parasites are living, and within these parasites, several hyperparasites are living. So number is getting increased when we move from base to top. So that's why in a terrestrial ecosystem, particularly if we consider tree as an ecosystem, then we can have inverted pyramid. Okay, but whereas not the case with respect to aquatic ecosystem or pond ecosystem or lake ecosystem or marine ecosystem, like this. Okay, so in an aquatic ecosystem, usually pyramid of numbers would be upright, usually upright. Is that clear?
Okay, sir.
Okay, so that is one thing. So here, the next thing that we have to keep in mind is that there are some other terms called bioaccumulation and biomagnification. So biomagnification. So we have to understand what are these two words. So what do you mean by bioaccumulation? Okay, so when we talk from the perspective of in an ecosystem, usually there can be various chemicals or there can be various pollutants. So when an organism consumes its food, so along with the food, an organism might also consume certain chemicals or certain pollutants. If water is polluted, or if the grass is polluted, or if like, let's say on the grass, there can be certain chemicals being sprayed, or we can have such kind of pollutants might be there. So bioaccumulation refers to what? Bioaccumulation refers to, it is the process of accumulation. It is the process of accumulation of various chemicals or various pollutants. Various chemicals or various pollutants within the body of a particular organism, or within a particular, either it can be within a particular organism or within a particular trophic level. Let's say, for example, there is a fish. Fish is directly feeding upon something in the water, and the water is polluted. So as the fish is continuously feeding on the same food, which is contaminated with a particular pollutant, so usually the pollutant levels may get concentrated, or the amount of the pollutant may get accumulated within the body of a particular organism within the same trophic level. Okay, so fish will form only one trophic level. So such kind of accumulation is nothing but bioaccumulation. Are you getting that? And here you remember that bioaccumulation occurs within a particular trophic level. This statement you have to remember. It occurs within a particular trophic level. And in contrary to this, there is other term called biomagnification. So what do you mean by biomagnification? Means it is nothing but biomagnification is nothing but it is the tendency of the pollutants or chemicals. Biomagnification, it is generally nothing but it is a tendency. It is the tendency of either pollutants or chemicals, either pollutants or chemicals, to increase in their concentration when they pass from one trophic level to other trophic level. Are you able to follow that? Producers are there, primary consumers are there, secondary consumers are there, tertiary consumers are there. So they are there. So it is the tendency of the pollutants to increase in their concentration when they move from one trophic level to other trophic level. So such tendency of the pollutants to increase in their concentration in the ecosystem or different trophic levels is nothing but biomagnification. Biomagnification. So why this will happen? Usually, you see, generally, there can be phytoplanktons. Let us say, phytoplanktons are there. And assume that water is polluted and phytoplanktons have absorbed that pollutants. Now, the water, the polluted, the chemicals that are absorbed by these phytoplanktons would be consumed by the zooplanktons. Zooplanktons. And now, this zooplanktons would be eaten up by some fishes, let us say. Okay, leave about small fishes, large fishes. So we'll take here this as food chain. And now, assume that zooplankton it would be feeding upon the phytoplankton. And regularly, if a particular zooplankton feeds on a phytoplankton, so concentration of the chemical will continuously, it will reach this pollutant. And now over a period of time, the zooplankton might accumulate more and more chemical. And in the main course of time, the fish may eat this zooplankton, and the same fish may keep on eating other zooplanktons also as well. So what will happen? So the pollutants will get transferred or they will get accumulated from one trophic level to another trophic level through the form of food chains or food webs, and their concentration goes on increasing when we move from lower trophic level to higher trophic level. Because large fishes cannot be eaten up by small organisms, so they will be hardly eaten up by the birds or something. So their longevity would be more. So over the course of time, they will accumulate more and more pollutants. So their concentration will increase when we move from the lower trophic level to higher trophic level. So likewise, this process or this tendency of the pollutants is nothing but biomagnification. Okay, and as their concentration of pollutants, it is getting enhanced or it is getting increased, or the concentration is getting raised. So we can also call this process as bioamplification. Bioamplification. Have you heard about amplifiers, which would be there for the speakers? Now, for example, if you are speaking in the mic, so obviously voice is getting enhanced and amplified, and we are getting in the louder. That means tendency of increase in the some output. So here also what is happening? The chemical concentration is getting amplified when we move from one trophic level to another trophic level. So this process is known as bioamplification. Okay, and now we are saying that the concentration of pollutants is getting increased. So for this process to happen, there are certain specific conditions. Not all the pollutants will become biomagnified. There are certain pollutants with specific characters which have the ability to become biomagnified. So what are the characteristics and what are the examples for that pollutants? So here we have to understand the characters or characteristics for the pollutants. So for example, if we talk from the pollutants point of view, there are 4 important characteristics. So If we talk from the conditions or characteristics, you can make like conditions also. So first condition, if you talk, a pollutant should be long-lived. That means the longevity of the pollutant should be more. So a pollutant should be long-lived in the environment. That means it must stay in the environment for longer times. For example, if it gets degraded within 1 day, then obviously this particular chemical can get biomagnified. So it is not possible. So a pollutant should be long-lived, or it should stay in the environment for longer period. So that is one thing. And then if you see other things, so the pollutant should be stable in the environment. It must be stable, and it should be mobile in the nature. That means it should be stable. So once it is released in the environment, it should not get converted into other forms quickly. So it has to be remained in its original form as it is. Another thing is that it shall have to have the ability to move from one organism to other organism. If it cannot move from one organism to other organism, obviously it would be the process of bioaccumulation, and it may not lead to biomagnification. So then, next important condition for a chemical or pollutant to become biomagnified is it is nothing but it should be soluble in the fats. It should be soluble in fats. When a particular pollutant is soluble in the fats, so then it can store or it can remain in the body for longer period. Because if it is water soluble, it can be eliminated by the organism in the form of excretion. So in the form of urine or in the form of excretion, that can be released. So if it is soluble in the fats, it can be stored in the body, and thus it can become long-lived, or it can become mobile. So that is one thing. So next important and final condition is that the pollutant should be biologically active. Pollutant should be biologically active. Biologically active means it should be actively taken up by the body, and it should be actively show its impact on the body of the organism likewise. That means if it is inert, that means if it is not causing any harm to the organism, so then what's the problem for us? Like, for example, if there is no harm from that pollutant or from that chemical, can we call it as pollutant first of all? We cannot call. And if it is causing causing harm to the organism, then we can call it as likewise. So it should be biologically active, and it has to show its impact on the living organisms. So these are the 4 important conditions for that. So if you look from this point of view, so can you name some of the common examples for the biochemicals that have the ability to become biomagnified? Yes, very good. So one common example is DDT. So DDT. So DDT means dichloro, diphenyl, trichloroethane. Dichloro, diphenyl, trichloroethane. So it is one generally commonly used pesticide or insecticide, which is commonly used, DDT, for sanitation purposes. Okay, we will use it. So DDT is an insecticide, or basically it is a pesticide we will use. And it is used generally in the agriculture, DDT. And this has all that possible conditions. It is long-lived, it is biologically active, it can be stable, and it can be mobile, and it can be fat soluble, likewise. So DDT is one example. Okay. So then, if we talk from DDT point of view, DDT was the one chemical that has been used in military during World War II. During World War II, DDT has been first used as used to control the malaria as well as the typhoid. So at the time, in the World War II time period, so as they used to stay in the hard terrains or like outside, So there were so many insects like mosquitoes and all those things. So in order to kill those mosquitoes, and to control such diseases like the malaria, typhoid, they have used for the first time DDT. Okay, and then we started continue use of it in agriculture likewise. So that's how it has started. So it is an insecticide and it's a pesticide. Then we have some things called hexachlorobenzenes. Hexachlorobenzenes. So hexachlorobenzene, it is a fungicide which is used to kill fungus. So HCB or hexachlorobenzene also has the similar properties. So it can also become biomagnified. So then we have PCBs, polychlorinated biphenyls. PCBs, we will call them as polychlorinated biphenyls. So usually we can see this polychlorinated biphenyls or PCBs in electrical appliances. From electrical appliances, they would be released likewise. So PCBs also have the ability to get biomagnified. Okay, and in the similar fashion, there are some other chemicals called like toxaphene. Toxaphene, it is another chemical which is commonly used as pesticide or insecticide. So toxaphene, so that is one thing. And then we have other chemicals like, let's say, methyl mercury. Methyl mercury. So it is another pollutant that has the ability to become biomagnified. So all of them might be either, some of them might be like pesticides, insecticides likewise. So in simple manner, we can say all the biocides. Biocides means like pesticides, insecticides, or agricultural herbicides. So they may have the ability to become biomagnified. So that is one thing. And apart from this, there are some other chemicals that can be released from petroleum products. So there are some petroleum products like polynuclear aromatic carbons. Polynuclear aromatic hydrocarbons that are being released from the petroleum or petroleum products. So they also have the ability to become biomagnified. So polynuclear aromatic hydrocarbons, you can mention like HC. Okay, so they also have the ability to get biomagnified. And apart from this, there are so many heavy metals. So heavy metals, let's say anything like mercury or cadmium or arsenic, or we have a lot of heavy metals. So it can be mercury, copper, chromium, lead, arsenic, all those things. They also have the ability to just get biomagnified. Okay, and apart from this, things like cyanides. Cyanides also have the ability to become biomagnified. Okay, so refer and try to learn various examples for those chemicals which have the ability to get biomagnified. So usually cyanides would be biomagnified in fishes, in fishing, cyanide fishing. We can remember, we can have such kind of things. Okay, so likewise, there, that is with respect to biomagnification and bioaccumulation.